As you now know what databases and tables are, let us go ahead and create some databases and tables in Hive. So first we'll have to get into Hive command line. I'm already logged into EMR cluster's primary node and type Hive. So it will open the Hive CLI or command line interface. So once opens, then we'll start creating databases and tables in Hive. So the prompt is here. We are already in the Hive CLI. The first thing that I want to show you is something called a configuration parameter, which is hive.metastore.warehouse.directory. It tells you what is the directory where your databases and tables would be created. So if you just type set and the name of the configuration parameter semicolon and press enter, it will show you the current configuration value. So if you see, the current value of Hive Metastore warehouse directory is user Hive warehouse. So let me go and see that in the HDFS file system. So I have opened another terminal wherein I have logged in as Hadoop in the primary node of EMR cluster. We want to see the user directory. So if you see in the user directory, I have user Hadoop, user HBase, Hive, root, Spark, etc. And this is the directory that we have already seen, user Hive warehouse. So if I go inside this user Hive, I'll be able to see the warehouse directory also. Let us go ahead and see that. And I should be able to see the warehouse directory. There should not be anything in the warehouse directory now. It should be empty now. So as you can see, this user Hive warehouse directory is completely empty. So let me go ahead and create a database and see whether the database comes here or not. By default, if you use the create database command, the database would be created in this particular directory. We can change this to any HDFS file and you can actually mention this as S3 also. Let us go ahead and do that. First, we'll go ahead and create some databases and tables in this using the same directory to understand how the directory structure is in Hive, and then I will change this Metastore warehouse directory to an S3 folder, and then we'll see how the data is stored in S3. Let me go ahead and create a database. The name of the database would be chapter 4db. Let me go ahead and create that. So this is the default parameter. You can mention a lot of other options like location. So if you do not mention anything while creating the database, the managed tables will be created inside of this directory only. And for the external tables, you'll have to mention the location by yourself. So now I have created this chapter 4db. Let us go ahead and see whether you can see that in the warehouse. So if you see, it has created an additional directory named chapter4db.db. So the name of the database was chapter4db, and it has created another directory. If you see here, this is a directory as it is preceded by d, and the extension is .db. Now what I'll do is that I'll go ahead and create a table in this database. Before creating a table inside of the database, you will have to connect to this particular database. To do so, use command. Use chapter4db will connect us to this particular database. Let me go ahead and create a table. Obviously, we'll be creating a much large tables and load data into it, but this is just for demo purpose. Just wanted you to understand how the directory structure works. So this table has been created. Now if I go and take a look at chapter4db directory, I should be able to see a directory for this particular table, which is EMP. So if you see, another directory has been created. The name of the directory is EMP. Let's see if we have anything inside of this of that directory or not. So as you can see, the EMP directory is completely empty. Let me go ahead and create a department table also. So department ID and department name, and now if I do an ls of the chapter4db, I should be able to see another directory which is dept. So I have created two tables, emp and dept. So Hive has created two directory inside of this database, and this database is located in user Hive warehouse, which is the current database directory for Hive. in this setup. Now let me insert some value in the EMP table. So now what it is doing is that it is actually running, converting it as a map reduce task in the Taze execution engine. It took around approximately 18 seconds. I'll go through this later on, not now. So the Taze job or the Taze DAG has executed on the yarn cluster. Now if I go ahead and take a look at the EMP directory, I should be able to see some file. So as you can see, this file has been created, and the reason that this file has been created now because I inserted data in this particular table. Let me do the same in department, but before doing so, let me see if there is any file or directory created inside of the department directory. The answer is no, there's nothing here. So I'll insert some data in department also. So I'm just inserting one row with ID 100 and department name to be big data. Again, it is running some Taze DAGs. So it took approximately 8.3 seconds. And now if I do an ls again on HDFS, I should be able to see a file inside of the DEPT directory. And this is how the directory structure works in databases and tables. Now if you run show databases command, it should be able to show you the database that we have just created, that is chapter 4 DB. You cannot drop the database directly. You'll have to drop all the tables in chapter 4 DB database. So if I try to drop the database, it says that the database chapter 4 DB is not empty. So I'll have to first delete the tables in chapter 4 DB database, and then I can delete the database. So I'll drop the table department and I'll drop the table EMP. So after dropping both the tables, the directories should also be gone. If I do an ls on chapter 4 db.db, I should not be able to see any directory for the tables. Now I can go ahead and drop the database chapter 4 db, and this should also remove the chapter 4 db directory. Now if I do an ls on user Hive warehouse, I should not be able to see the chapter 4 db.db. So as you can see, this directory is empty now. So as you have dropped the database, the directory has also been deleted. The next thing that I want to do is change the Hive Metastore warehouse directory to a directory that we have created on HDFS. What I'll do now is that I'll be creating a directory in HDFS and use that directory as the Hive Metastore warehouse directory in which all my Hive databases would be created. What I'll do now is that I'll be creating this directory dhive/db, and I should be able to create this in my root directory itself, root HDFS directory. So dhive has been created, and if I do a ls, I should be able to see the db directory also. Now what I'll do, I'll use this directory to be the Hive Metastore warehouse directory, and let me go ahead and change that. So how do we change it? So what to do here is that instead of just set followed by the configuration parameter name, I'll mention equal to and the value of the configuration parameter. So it has been set. Now if I try to find this value, again I'll type only just set and the configuration parameter name. So if you see now, this value has been changed to dhive/db. Now one thing is that I have changed this dynamically. Now, whenever I restart Hive, the change would be gone. So if you want to do it permanently, we will have to change it in the configuration file, that is hivesite.xml. But hivesite.xml is not available in EMR. In EMR, we'll be changing the configuration using a JSON file, which I'll show you later on. Now, as of now, let me go ahead and create a database. Name of the database would be dtest. So you'll see that this database would be created in dhive/db directory. If I do an ls, I should be able to see dtest database here. So if you see dtest.db has been created, If I go ahead and create tables inside of this database, those tables would be created inside of this directory. Let me go ahead and drop this database as this is empty. It has been dropped. I should not be able to see the directory anymore. So it is gone now. So we have played enough with HDFS. Now let us go ahead and do that in S3. So what I'll do is that I will change this Hive Metastore warehouse directory to an S3 location. And going forward, we'll be using S3 itself. The reason is that if you remember, HDFS on EMR is a temporary storage. If you terminate the cluster, the HDFS directory and data would be gone. So that's why I'll go ahead and create these Hive databases and tables in S3, because we'll be terminating the cluster multiple times, and the same thing can happen in production also. Let's say in a particular day you are running your cluster only for 8 hours or 6 hours or 10 hours, and the remaining 14 hours it remains completely idle. So if that is the case, you'll be using this idle timeout wherein you want to terminate your cluster, let's say after 1 hour, and the cluster would be terminated. So if that happens, your HDFS directory and data would also be gone. So that's why it's better to create or store these databases or database directories in S3. What I have done is that in the bucket DEMR bucket, I have created a folder named Hive, and all the Hive exercise will be done inside of this folder. So all the data that you do as part of Hive hands-on will be stored here. As of now, I have created three locations or three folders rather: S3D databases, S3D database 1, and S3D database 2. These are all empty folders, there's nothing inside of it. I just wanted to show you that. So what I'll do is that I will mention DE databases 1, S3D databases 1 as the location in Hive warehouse metastore directory. But before that, I want to show you that if this folder is not created also, it will be created by Hive. Now let me go ahead and set Hive warehouse metastore directory to be S3D databases. Hive metastore warehouse directory has been set to S3 DEMR bucket / hive / S3 D databases. You can see whether it has been set properly or not. So as you can see, it has been set to S3 databases. Now let me go ahead and create a database. I do not have this test folder created inside of the databases, which you have already seen. Let me show you again. So this is this DS3 databases folder, S3D databases rather. It is completely empty. If I create the database now, I should be able to see this folder being created. So as you can see, there's a metadata folder that has been created. Now if I go ahead and use this test database and create a table, now this table has been created inside of this test database. Let us see in S3. As you can see, test.db has been created, and inside of this there will be a S3 metadata folder. The folder for data has not been created yet, but it will be created once we insert data. Let me insert data in test.tbl. It will launch a test DAG, and it will take some time for the data to be inserted because it is running some execution engine. It's not running MapReduce, it is running test. I have told this many a number of times, but it's better to. If I take a look at this folder again, test.db, it should create a folder named test.tbl, and inside of test.tbl I should be having a file which should contain the data. The size of the file is only 5 bytes if you see. Now this is how you can actually use S3 as your Hive metastore warehouse directory, and you can create databases inside of this directory also. You do not need to create the folder beforehand, you can create the folder later on also. The next thing that I want to do is that I want to create a database in a different location than what is mentioned in Hive metastore warehouse directory. So this is S3DEMR Hive S3 databases. How do I do that? I'll be creating a database, let's say S3DB1, and I mention that using something called location followed by single quotation. Now in the location I can mention the folder that I have created, which is S3DB1. If you do not mention this folder, the folder would automatically be created. So this, so it has been created now inside of this. Now what I'll do is I will use this database s3db1, and I can create a table now in this particular database. And in the S3 folder, I should be able to see a metadata folder which has been created. The table directory has not been created yet because we have not inserted any value. Let me go ahead and insert values. It will run a test task. It took approximately 11 seconds. Now I should be able to see the folder with test.tbl, and it should have a file which is this one. Again, the size is only 5 bytes because the data is very less. Now let me go ahead and drop the tables and see what happens. I have this table test.tbl, and if I drop this table, the folder should be automatically deleted in S3 also. The behavior is exactly same. In S3 I should not be having this folder anymore. So if I go back to S3db1, so as you can see, this is empty. The folder has been deleted. The folder which was there for the table test.tbl has been deleted. If I go ahead and drop the database, this folder s3db1 would also be deleted. Deletion is successful, the drop is successful. If I refresh, I should not be able to see this folder s3db1. So as you can see, that folder has also been deleted. So what we have seen now, either we use HDFS or S3, the behavior of Hive is exactly the same. So that's why you can use S3 as a distributed storage instead of HDFS. Remember that S3 is exposed as EMRFS. So we are essentially using EMRFS on S3, which is behaving as a distributed storage like HDFS. Now the reason we are not using HDFS, because if you terminate the cluster, the data that you have stored in HDFS will be gone.